Welcome to Study Loop.
Okay, this is Chapter 11, Section Problem 108. The vapor pressure for pure water and pure acetone is measured as a function of temperature. In each case, a graph of the log of the vapor pressure 1 over T is found to be a straight line. The slope of the line for water is minus 4895 K, and the slope of the line for acetone is minus 6748 K. Determine the HVAP, or the heat of vaporization, for each substance. Account for the differences by discussing the molecular structure of the two molecules. Okay, so if you look in the book in example 11.4, it provides the kind of graph that probably these students were attempting to make, and it's derived by the Clausius-Clapeyron equation. And essentially, as it was saying, if you plot the natural log of p versus 1 over k, you get a line, you take the slope of that line, and then essentially the slope times r is equal to minus the heat of vaporization. Now, if you plug the numbers that they gave us in, we get heat of vaporization for water of 40.7 kilojoules per mole. And using the numbers they gave us, you get a higher heat of vaporization for acetone, 56.103 kilojoules per mole or whatever. That's ridiculous, and it's impossible. And I'm not sure if it's a typo or if the textbook is intentionally trying to throw us off. It's one of the two. If you go on Wikipedia real quick, you see that in fact, it does. Water has a higher heat of vaporization than acetone, and I'm sure if you looked into more reputable sources or literature too, you'd get the same answer. And water really necessarily is going to have more energy required to break go from liquid to a gas phase, because it has way more stronger intermolecular force of attraction, because water can hydrogen bond and acetone can't. So, it's a huge red flag that they calculated a higher value for acetone than for water, because it just doesn't make sense. I plugged into the equation real quick, like, well, what if they copied it down wrong? It's supposed to be 3748 instead of a 6748, and that gives you something, way closer to the answer that's on Wikipedia. It could be that the textbook writers just wrote that down wrong, or again, maybe they're trying to suggest that the students made a mistake in the experiment, which is also possible. When you're dealing with acetone, acetone is super volatile. It's really easy to evaporate, and maybe their temperature readings were wrong or something. But like straight up, it doesn't make sense the way that this question is written. Water has it has a lot more hydrogen bonding than acetone. Acetone is just a ketone. Acetone is like this. So, you've got a carbonyl here, but this can't, it does have an oxygen, but this can't go through hydrogen bonding, or can't hydrogen bond to itself. And that's why it's very volatile. Its boiling point is, 56 degrees Celsius, whereas water, which is, has a lower molecular weight, is 100 degrees Celsius. So either the students messed up or the textbook people messed up, but, generally speaking, water definitely should have a higher heat of vaporization than acetone, no matter what this textbook or these students are trying to report. They're probably going to lose a lot of points on their lab report, is the moral of that story. So there's really nothing to account for this discrepancy, given the way that the problem is worded. But in actuality, water is going to have a higher value. So let's see, determine the HVAP for the substances. We kind of did that according to their numbers. We've got these are the numbers based on their values. 40.7 kilojoules per mole for water and 56 kilojoules per mole for acetone, but that's not the right answer. So anyway, hope this helps. Again, this is a derivation. This problem is utilizing the Clausius-Clapeyron equation, and it's really easy to kind of plug in. But you always want to make sure that you're calculating slope correctly. Yeah. Anyway, good luck studying.